We're gonna go over Euler's formula. It's Unit 3, Assignment 2. I'm gonna send a link on kind of a better explanation of it, but I just want to go over the questions with you guys. Whoa. All right, so you vocab like always. We've talked about this in other units. It's just talking about vertices, other points. Base is like the bottom of each one. The edges are almost each line that they're talking about. Vertices are the points. So there's only 8 questions. I'm just gonna go through. Just probably 2 through 6 with you guys because it's a little a little wordy. So it says, which solid has 5 faces, 4 lateral faces, 1 base, 5 vertices, and 8 angles? So square, pyramid, triangular, prism, triangular, pyramid, triangle, prism. So if we can look back up at our shapes up here, square, pyramid, we can look at this one. This is square pyramid. It says how many bases does it want? It doesn't say any bases. So 5 faces. Let's see, 1, 2, 3, 4, 5. 5 bases, 4 lateral bases. So we're going up 1, 2, 3, 4. That works. Oh, it does have base. 1 base. That's that red one right there. And then 8 edges. So on the lines, 1, 2, 3, 4, 5, 6, 7, 8. Yep. So it has to be that one. I challenge you guys to, when I'm doing these videos, really just pause it, answer the questions, try to figure it out yourself, and then play my video and see if you guys get it right. So this one says, which solid has 6 faces, 4 lateral faces, 2 bases, 8 vertices, and 12 edges? So it's easier if we look at the shapes. 2 bases, does it eliminate any of them? Maybe triangular prism, triangular pyramid. So square, it's not going to be square pyramid because we just did, but let's just double check with rectangular prism. So 6 faces, we go back up here. 1, 2 on the back side, 3 up top, 4 on the bottom, 5 on the right, 6 on the left. Perfect, Kev. 4 lateral faces. That just means pretty much up and down. 1, 2, 3, 4, not counting the bases, what we're doing there. 2 bases, we count that. 8 vertices, so 8 points. 1, 2, 3, 4, 5, 6, 7, 8, perfect. And 12 edges, so 12 lines essentially. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a better way to explain it. Now to determine the number of edges, we need to identify every place where the faces meet. So they meet exactly every line essentially. So that works too. So it has to be rectangular prism. So these are different but similar. Which solid has 0 faces, 0 bases, 0 vertices, and 0 edges? Sphere, cylinder, cone, cube. The only one that has 0 is probably going to be a ball, or it's going to be a ball. So, or a sphere would work too. Number 5. So which solid has 2 faces, 0 lateral faces, 2 bases, 0 vertices, 0 edges? So a cube, we know a cube is going to have multiple vertices. A sphere has 0 bases, and it's saying it has 2 bases right there. A cylinder could work, or a cone. A cone wouldn't work. Let me do this for you guys. Oh, my dog just came in. A cone wouldn't work because a cone would have just 1 kind of base if you flip it upside down. So cylinder has to be it, because if I have something like this, whoa, excuse my drawings, okay, it has 2 bases, 2 faces, that's a face, that's a face, or bases, sorry, or faces, 0 lateral, so 0 going like sideways, up and down, 2 bases, 0 vertices, and 0 edges. So that should work. You guys hear him? Hold on real fast. My drawing mouse. Perfect. All right, you want to say hi? Oh. Okay, he'll do the next one with us. Clear. Which solid has a face, 1 face, 0 lateral faces, 1 base, 1 vertex, and 0 edges? So 1 face, this is what we did, I drew with the cone. So cube would have a bunch, a sphere would have 0, cylinder would have 2, but a cone, think of an ice cream cone, it has 1 face, and faces and bases are not the same, kind of like what I said last time. 1 face, 0 lateral faces, 1 base, 1 vertex, and 0 edges. So it has to be a cone. All right, his formula is essentially, like, gets really complicated, and you guys get to have fun with that in high school. For right now, it's just it's not complicated, but a lot more elaborate. For right now, this is all you guys need to know, where my mouse is. V is vertices plus F is faces equals edges plus 2. So there's not many problems on this for you guys, but we can go through the examples. So if we're doing this one, this rectangular prism right here, it has 6 sides, 6 faces, 1 back, 2, 3 up top, 4 on the bottom, 5 on the right, 6 on the left. Okay, so we put that was faces, so we put that right here. For F, we have 8 vertices, so we just count all the points, 1, 2, 3, 4, 5, 6, 7, 8. Plug that in right here, vertices. Then we have 12 edges. Remember, edges are just when they come, 2 faces come together at a point, so it's just the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We plug that in. And the formula is just saying that when you do this, they equal each other. So we have 8 vertices plus 6 faces equals 12 edges, and then it's always plus 2 because it's the formula. So 14 equals 14, and that works. Okay, same thing for this one. We have 5 vertices, 1, 2, 3, 4, 5. We have 5 faces, 1, 2, 3, 4, 5 on the bottom. We have 8 edges, so lines, 1, 2, 3, 4, 5, 6, 7, 8, and then plus 2. So all equal each other. Same thing right here. You just plug in. So most shapes work. The only one that doesn't work, and this sentence explains it right here, is a solid sphere. That does not work for the formula, because when you plug it in, 0 is not going to equal 2. Number 7, just asking what the formula is. You guys can do that one on your own. And for this one, you guys are going to do it on your own too. The best way to do it is either go to the very top and count all the sides, or just go on Google and type in each one. Type in triangular prism, rectangular prism, count the faces, okay? And then all this is filled in for you, so it's not that bad. So you got 1, 2, 3, 4, 5, 6, 7, 8. You guys can do it on your own. Good luck.